Hey, welcome everybody. This is part 1 of lesson 8 of our geometry unit, the final lesson. Today our objectives, we're going to learn how to use a protractor, compass, and ruler to construct triangles. We're going to define triangles by their sides and angles. And then we're also going to understand the relationship a bit better between interior and exterior angles of a triangle, which is the angle sum theorem and the exterior angle theorem. So let's move into exercise number 1. So what I want you to do is I want you to actually try this first one on your own. Construct a triangle ABC with sides measuring exactly 4, 5, and 6 centimeters long. So I want you to pause the video and try to draw that triangle and write down what steps you use to do that, and then I'll show you a method you could use in case you're having a hard time. So pause the video now, please. Okay, now that you've come back and you've unpaused the video, you should have a triangle here that hopefully you tried to create with these sides. Now we are going to construct that triangle ourselves, and I'm going to show you how to do that using, we've got our ruler, we've got our protractor, and I'm going to show you how to use a compass. Now if you don't have these 3 things at home, don't worry, I've got them in class for you. But still I'd like you to follow along with the video. So this is how we can make that triangle. First we're going to start by creating a line that's going to be the longest of our 3 lines. So that in that case that is 6 centimeters. So I'm going to make a line that is exactly 6 centimeters in length. So there is my 6 centimeter long side. And now what I can do using my ruler and using my compass, I'm going to take my compass and I'm going to make the 4 centimeter long line. And the way I do that is I actually measure out 4 centimeters with my compass. So I'm going to measure out, I'm going to go out to 4 centimeters, okay? Now, I'm going to go to one end of my triangle and I'm going to draw an arc. And what I know about that arc is that at any point in time from this point, all points going to that arc are 4 centimeters. And now I'm going to do the same thing. I'm going to do it for 5 centimeters. So I'm going to take my ruler and I'm going to measure out 5. Oops, hold on, let me put that down there. I'm going to measure out to 5 centimeters, so right about there. And then I'm going to go to the other end of my triangle and I'm going to make that arc. And I don't have to do much. I just have to see where do they intersect. That intersection will make my triangle. So if I go from here to here, that's going to create for me, or should be very close, that should be my 4 centimeter long line. And if I measure it, I can see it is 4 centimeters. And then the other connection from there, I make that, that should be a 5 centimeter long line, and you can see that it is. So we've got 5 centimeters and 6. And that is a very, very easy, simple way to make triangles with specific dimensions. And then if we want, we could use a protractor to actually find out what the angles inside are. Okay, so let's try that again. Let's construct a triangle with the sides measuring 3, 5, 7. Again, we start with our longest side. So I'm going to put that down here as far down as I can. I'm going to make a side that is 7 centimeters in length. And then I'm going to set my compass to first 3 centimeters, right about there. And then again, put it on my end. Draw an arc, okay, and then the other one is 5 centimeters. Let's get that set up, and that's pretty close, 5 centimeters, and I'll make my line. Okay, and you can see the point at which they intersect. So this is my 7 centimeter long side. This is going to be 3 centimeters, and 5 centimeters. So a very, very simple way to create triangles using a ruler and a compass. Okay, so now let's move to exercise 2 in here. Says, given the findings from exercise 7, that was the last one here, what must be true about the relationship between angle ABC, so that is this angle here, angle BAC, that's this angle here. Notice the middle letter is what we always, and exterior angle BCD. That means this angle here. What is the relationship between them? And the answer is this: when we're dealing with a triangle, whatever the angle measurements are, we know that these three angles inside add up to 180 degrees. But what's also unique about triangles is that this last unknown angle, angle C, this exterior angle is actually equal to both of these angles added together. So what that means is angle A plus angle B will equal exterior angle C. And that's a very, very important piece of information to learn. Okay, here's another exercise you can do where you can cut out a triangle yourself and try that out. And then you can make some observations, draw some conclusions. But we're going to go down here to the interior angle theorem, or triangle angle sum theorem. And what it says is that all angles inside a triangle have to equal 180 degrees. And most of you already know that. We've been using this detail for quite some time. But then to go with it, we can put together with the interior angle theorem the exterior angle theorem, which is the sum of the two angles that are opposite the exterior angle. The exterior angle are congruent. Oops, there we go. Congruent to the exterior angle. Okay? So again, what we're referring to, if we were to have a triangle, okay, something like this, if we have angle 1, angle 2, exterior angle 3, we know that angle 1 plus angle 2 is always going to equal that exterior. So these are the two angle sides that are opposite, because they are across from it. They're opposite this exterior angle, and they will be equal. Okay? All right, let's move on to exercise 3. We can look at some details. We're going to draw the perpendicular bisectors using a compass and a ruler. Okay? So hopefully this will be another piece of information that will be fairly simple. So let's talk about a segment bisector. Segment bisector is a line that passes through the middle of a segment. And then a perpendicular bisector is a line that passes through, again, the middle of a segment, and that is also congruent. Sorry, you guys can't see that there. It's at the bottom. So again, segment bisector is a line that passes through the middle of a segment, and then a perpendicular bisector is a line that passes through the middle of a segment and is also congruent. When we come back, we will look at how we can do that with these images.